Welcome back. We are looking at worksheet D4, which is on amplitude and period, and we're now on page 2 of the notes. So we're going to look now at the parent function for the cosine graph. And so we again want to graph this on the interval from 0 to 2 pi. And so just like with the sine graph in the previous video, we'll make a table of values. And for the x values, once again, we'll pick the values that are on the unit circle that are the quadrantal angles. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. And then we'll come up with the corresponding values. So again, for the first one, we're putting 0 in for x in the cosine graph, so we get y equals cosine of 0. And if you think about this ordered pair, that's the ordered pair 1, 0. So the cosine is equal to 1. And then again, I'll let you fill in confirm the other values yourself, but as you go around, the cosine of pi over 2 will be 0, cosine of pi will be negative 1, cosine of 3 pi over 2 will be 0, and then back to the cosine of 2 pi, which will be 1. Then we want to graph that one period, and so on the x-axis, again, we'll put these values from 0 to 2 pi, so 0 to 2 pi, and then in the middle we have pi over 2 at what I'm going to call the quarter point, and then 3 pi over 2 at what I'll call the 3/4 point. And then the cosine function will go up as high as 1 and down to negative 1. And so again, if I want to graph the points that go with that, I've got the point 0, 1 to start with, and pi over 2, 0, pi negative 1, 3 pi over 2, 0, and then 2 pi 1. And so again, we want a nice gentle sine curve that goes through those points. So notice that for the cosine curve, if we look at one period starting at 0 and going to 2 pi, that this one starts up and ends up. And in the middle it goes down, and then at the quarter point and the 3/4 point, it's going to be on that principal axis. So the domain for this one is, all of this information is going to be the same as the one that we had for the sine. So quickly, domain is going to be negative infinity to infinity. In other words, all real numbers. The range again goes from negative 1 to 1. The period is 2 pi. Right, that's the distance that it takes to repeat one cycle. Amplitude is 1. Again, that's the distance from the midline to the high point or midline to the low point. Equation of the principal axis is still y equals 0. So we're talking about this line, and then the maximum function value is 1 and the minimum is negative 1. So let's take a look now at some of the examples. And so the worksheet is structured that you'll have a couple of examples for different types of problems and then problems for you to practice. So let's take a look at the first set of examples, and notice that for these problems we're looking at functions that are of the form a times sine x or a times cosine of x. And we've talked about the fact that that number is going to give it a vertical stretch. And in this case, not only a vertical stretch, but also a flip. So I'm going to make a note of that so that I hopefully don't forget to flip that. So when we do this graph, we'll just, again, it's not on a graph paper, so it isn't necessarily drawn to scale, but we'll kind of sketch out, and we want to label, at the very least, the x values and the y values of the 5 key points. And I'll point out that the 5 key points for the cosine graph are these 5 points that we just found. So for this graph, as we said, the negative 2, the amplitude is the absolute value of negative 2. So that's going back to the formula that we had on page 1. And so the effect of that is going to be to take the regular sine graph, which looks like this, and stretch it away from the x-axis, but at the same time flip it. So basically it's going to do this. So what we'll do is on the y-axis label that the high value is going to be 2 and the low value is going to be negative 2. And that comes from the fact that this principal axis doesn't change with this stretching. And the amplitude is defined to be the distance from that principal axis to the high value and then down to the low value. So we'll go up to 2 and down to negative 2. For this one, the period doesn't change at all. As I stretch this away, it doesn't change the distance that it takes to go through that one cycle. So this part still is going to be 0 to 2 pi. The middle point is still pi. The quarter point is pi over 2, in other words, a quarter of the way across here. This is halfway across. And then the 3/4 point is 3 pi over 2. Then when we sketch the graph, basically these values that are here, the -2 and the 2, and the 0 and the 2 pi, kind of define a box for us. And we know that the 1 period is going to be within that box. But what will happen is, because this is the sine graph, it's going to be, the behavior is that at the first point, the middle point, and the end point, it's going to be on that principal axis. And then at the quarter point, usually the sine graph goes up, but because of the flip, it's going to go down. So it's going to go down to -2. And then at the 3/4 point, where normally it would be down, because of the flip, it's going to go up. And then the graph is going to look like this. And I'm not going to show this on the video, but you can also check this with your graphing calculator, and I would encourage you to do that, so that you would put this y equals -2 sine x in for your y function. And then when you go to window on the graph, what you'll do is, for your x min, you'll put in 0. For your x max, you'll put in 2 pi. For your y min, you'll put in -2, and your y max 2. And so what that will do is it'll turn your graphing calculator screen into just this little box. And then if you just press graph, you should be able to see that identical graph. All right, I'm going to do the y equals cosine, 1/2 cosine x with you. What you might want to do is try this on your own first. Turn off the video, try it, and then turn the video back on again to see how you did. So y equals 1/2 x. So for this graph, the amplitude of this is going to be the absolute value of 1/2, which of course is 1/2. And because this is positive, it's not going to flip the graph. So let's start here. Again, what this is going to do is a vertical compression. It's going to press the graph toward the x-axis. So it's going to push it this way by a factor of 1/2. And so the principal axis doesn't change, but I am going to go 1/2 above. So I'm just going to label 1/2 here and -1/2 here. And then the period doesn't change as we do that compression. So once again, this is going to behave just like the parent function. It's going to go from 0 to 2 pi, with the value in the middle being pi, and then the quarter point pi over 2, and the 3/4 point 3 pi over 2. So once again, what these values do is they kind of define for us a box. And we know that the graph of the cosine is going to be within that box of 1/2 cosine of x. But the cosine graph, remember, behaves in the way where at the beginning and the end, it starts up and it ends up. And then at the middle value, it goes low. It's going to go to -1/2. And then at the quarter point and the 3/4 point, it's going to be on that principal axis. And then once again, I can just connect that with a nice smooth curve. And once again, I would encourage you to check this on your graphing calculator. Put this in as y sub 1, and then put your window in, your x min, x max, y min, y max, and then you should see in your window this graph exactly so that you can check it. We'll stop there, and we'll do another video for the next page.